Okay, on to another optimization problem. This one is number 5 from the homework. So a nice little introduction, a nice little simple take on the maximization, minimization problems. For a rectangle with a perimeter of 80 to have the largest area, what dimensions should it have? Okay, so here's our rectangle. And we know because it's a rectangle, the sides have to match. So the heights have to be the same dimension, the widths have to be the same dimension, and the perimeter is equal to 80. It's funny they don't say a value equal to 80. 80 what? So the perimeter is 80 mystery units, I guess, and that's going to be x plus y plus x plus y, also known as 2x plus 2y. So there's the equation of the perimeter. All right, and it's written in terms of x and y. So for a rectangle with a perimeter of 80 to have the largest area. Okay, so largest area. That's what we want to maximize. So recognize the area is simply x times y. Alright, and because the area is what we're after maximizing, I need to redescribe the area in terms of only one variable. Typically we like to look at x, so we need to take this relationship and isolate y and shove it back in to this area equation. So y is, well, 80 minus 2x over 2, which I can simplify a little bit. 80 over 2 is 40. Negative 2 over 2 is negative 1. So there's my relationship between y and x. I'm going to take this and shove it in for y. So area is x times y, which we're now calling 40 minus x. Alright, so let's take a look at this area equation. I'm going to write it in functional notation. So a of x, and that's because this area is dependent upon my variable x. So a of x is 40x minus x squared, distributing the x across my 40 and my minus x. So again, I get a nice little quadratic equation, and I need to differentiate. So here's my area with respect to x. It is equal to minus x squared plus 40x. So a prime of x, the derivative, is minus 2x plus 40. And I need to set this derivative equal to 0 and solve for the values of x that make that true. So I would subtract 40 and divide by negative 2 to get 20. So because x is 20, this says y is, using this relationship, or similarly this relationship, or this relationship, that would be a nice one. So 40 minus x, well, x is 20, so 40 minus 20 is 20. So the area, when maximized, is 20 times 20, or 400. Rectangle perimeter 80, have largest area. What dimensions should it have? Also, be aware to read these problem statements carefully. In this one, enter the smaller value first. So do take notice of these statements. You could do all the work right, punch it in incorrectly, and the work would be right, but it doesn't recognize that it's right. So in this instance, recognize X and Y were the same, so of course it doesn't matter which one you enter first. All right, I will let you tackle 6. 6 is very similar to 5, the one we just did. However, in 5, we were maximizing the area, so it was the area that we took the derivative of. In number 6, you are going to minimize the perimeter, so you'll want to differentiate the perimeter equation. All right. So I'll let you work on these, and I'll see you on the next one where we go over number, yeah, we'll go over number 7 on the next one. All right, see you on the next one.